What we're looking at now are graphs of sine and cosine functions that have horizontal and vertical translations. We're just going to look at a few different examples, and this example we've got here to start with is looking at sketching the graph of y equals 3 sine of 2 times t minus pi on 4 over the domain from pi on 4 through to 5 pi on 4. So as with other graphs, what we're going to do to start with is write down our amplitude, so we know our maximums and minimums, or at least gives us a guide for that. So amplitude here is 3, our period for a sine function is 2 pi over n, and our n value is this 2. So that's 2 pi over 2, which is pi. So it goes through one complete cycle in pi units. Okay. What we've got here is in the brackets t minus pi on 4. Now, as with other functions that we've looked at, when we have in the brackets our x value, or our whatever our independent variable is, plus or minus some value, that gives us our horizontal translation. So t minus pi on 4 means that our original sine function is going to be translated to the right pi on 4 units. Okay, and we'll see that when we graph it. Okay, so, and it's also called a phase shift. Okay, so it's a phase shift of pi on 4 units right. Now, because we've got here a little bit different in terms of our domain, it's worthwhile working out what our starting and finishing points will be. So what we're going to do is we're going to let our t value here equal pi on 4 so that we can determine what our y value is, because this is going to help us determine our endpoints. Okay, so for our endpoints, it means we need to know what our x and y values are here. Well, not our x value, but our t value is pi on 4. So what's our corresponding y value? So if t equals pi on 4, then our y value will be 3 times sine 2 pi on 4 minus pi on 4. So what we've got then is 3 sine 2 times 0, so that's 3 times sine of 0, and sine of 0 is 0, so 3 times sine of 0 is 0. So that means what we have is our starting point, if you like, is pi on 4, 0. Now, you'll notice here that our period is pi, and what we've got here is a difference of pi. So from pi on 4 to 5 pi on 4, that is pi radians, and we know that our period is pi. So we could work it out again, but it will be the same, that if t equals 5 pi on 4, our y value also will be equal to 0 as well, because it's going through that one complete cycle. It's back to that same starting point. So we've got also this point here, 5 pi on 4, 0. Okay, so we're going to sketch our graph. Of y against t. Now we've got pi radians. Now it's going to be worthwhile, I think, if we just mark in pi, because our period is pi, and it will divide up nicely anyway. So we've got pi on 2 here, and this will be halfway between that, so that's pi on 4, and we've got this point here, which is 3 pi on 4, and we're going to be graphing to 5 pi on 4, so we're going to go the same distance again. So again, make sure you're careful with your scaling. So that's 5 pi on 4. Now we know our starting point, and our amplitude is 3, so in red. So that's 3 to -3. And we've got our starting point at pi on 4, 0. We're getting to our end point here, 5 pi on 4, 0. And we know that our sine starts halfway, and because it's not reflected, it's going to go straight up, and down, and then up again. So it's starting and finishing on the x-axis or the t-axis, and it's going through one complete cycle. So that means it's going to be passing through here as well. Okay, so it's got a t-intercept here at 3 pi on 4. It's going to be at its maximum halfway between these 2 points, which is at pi on 2. So we can put a mark there, and it's going to reach its minimum value halfway between these 2 points, which is at pi. Okay, so it's this. We've marked in our relevant positions. We can now sketch. Okay, so we've got it nice and clear here. Axis intercepts, pi on 4, 3 pi on 4, and 5 pi on 4. Endpoints is at that same point here and here. And we can see our maximums and our minimums are there. So that's nice and clear as well. So that's all that's really necessary in this particular sketch.